Let's now look at the most difficult question in the set. You have 8,436 balls that you are stacking, starting from 1 on the top, 3 in the second layer, 6 in the third layer, and so on. Now you have to find the number of layers in this pile. Now, first of all, let's understand what do these numbers 1, 3, and 6 mean. 1, as we already know, is sum of 1. 3 is sum of 1 and 2. 6 is the sum of 1, 2, and 3. So we get the hang of it, right? Each number in a layer is basically of the format n into n plus 1 by 2, right? And starting from layer 1, I have to find out how many layers are there, right? Till layer n. Okay, so now I'm going to sum up this number, right? I'm going to sum up n square plus n the whole by 2. So first of all, let's quickly look at the n square summation. Summation n square is n into n plus 1 into 2n plus 1 the whole divided by 6. Okay, so we already know what summation n is. Now we know summation n square also. So how would we solve it in the equation format? This is what it will look like, right? You will break up n into n plus 1 by 2 into n square and n, and then you will sum them up individually. So you will get summation n square leading to this horrible thing, and then you'll have summation n leading to n into n plus 1 by 2, and divide the whole thing by 2 to get a cubic equation. Rejoice! Today is your lucky day. Solve a cubic equation. No, we are not doing that, you know, right? Let's see how to solve this now. Okay, so what is interesting to see is that whether it is summation n or whether it is summation n square, they both have this thing in common. They are both multiplied with n and n plus 1, right? Which means if we add them up also, the sum would be a multiple of n and n plus 1. Great. Now if n plus 1 or n is a prime, then we can just check whether 8436 is divisible by that prime or not. So let's start looking at options, right? Let's pick up the first option, 34. If 34 is n, your n plus 1 will be 35. So I'll quickly check for 7. It's very easy to check. 84 is a multiple of 7. 36 is not. So the whole thing is not a multiple of 7, right? And that's why we can eliminate option 1. Between option 2, 3 and 4, I'll check for 4 first. Let's just check which option is easy to check. So if n is 32, n plus 1 will be 33. Great, so we'll just check for 11. Is 8436 a multiple of 11? If you check, 4 plus 6 is 10, 8 plus 3 is 11. So no, this is not a multiple of 11, and hence your answer cannot be option 4. Great, now option 2 and option 3. Option 2 is better because n plus 1 is a smaller number to check. Let's see. If n is 38, n plus 1 will be 39, right? And hence I can just check for 13. Remember, checking for 3 is not sensible because you're going to divide by 6. You're going to divide by 2. So we'll not check for 2 and 3. We'll check for other primes, right? I could check for 19 also, but why check for 19 when 13 is a smaller number? So is 8436 divisible by 13? You can find out it is not. So you can eliminate option 2 also. We are only left with option 3, and that is your answer. So let's look at some of the things we have done. We have not worked with 2 and 3 as a multiple, right? Because we are going to divide by 6. And we have not checked for options in a linear way starting from 1 to 3, 4. We have checked for options where the smaller primes exist so that we can eliminate more easily. Right? So great. This wraps up our day one. Now I'll go read a book and you have a good day.